Cool. Let's do it. Here, bud.
Oh, it doesn't ask the epic 2 questions. Have you done the review? Are you meeting together?
Oh.
Okay, so number 1.
There it is.
What's up?
Number 1, I am actively participating in the lessons group meeting. Yep, we're here.
Oh, yeah, I need to pull the quiz up. All right. And meeting quiz.
You do realize that the prep is our quiz.
Correct.
So whatever you did.
Yep, correct. Yeah, I got all the way to like the last couple of questions, so got her.
I mean, I opened this stuff up on my break last night, and I thought, what is this thing? Is it like Greek to me again?
I decided I can't do any thinking when I work a night shift. I just have to sit there and I don't know. I'm terrible at nights.
I use my breaks and stuff, so.
I didn't even attempt homework.
I try to do it between calls.
Oops. We got
did we lose
internet
him?
issues. Yeah, we lost him.
Oh, shoot. Oh, everybody's frozen. Can you hear me, Wanda?
I can hear you.
Okay. My screen's all frozen.
Well, bummer. Mine's not.
Yeah.
There, Brian's coming back.
There you are.
What happened there, Guy? We missed.
I have no idea. It must be my computer. I don't know.
Okay, moving on to question 2. Given a 90% confidence interval of brackets 45, 105 for mean heart rate, which of the following is the best interpretation of this confidence interval?
The second one, right?
Yep, B. We are 90% confident the true mean heart rate is between 45 and 105. That's what I got.
I did as well. Is that what you got, Wanda?
Yep.
Perfect.
Sweet. Researchers at the University of Mississippi wanted to determine whether the reaction time to go/not go stimulus of males differed from that of females. Researchers randomly selected 20 females and 15 males to participate. The go/no-go stimulus required the student to respond to a particular stimulus and not respond to another stimuli. The researchers decided to construct a confidence interval to determine if their difference of the means is significant.
Jack, Mom went to the store.
To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
I put oh, sorry, they're all mixed up. I put A.
I put no because they selected 20 and 15, so that's under that in 50 for your standard of not having to do a QQ plot. But they did a QQ plot because of that. So through the QQ plot, they said it was normalized, correct?
Uh-huh. Well, isn't the sample size large enough because it's
over 30, right?
Yeah.
In combination.
So I thought it would be yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
And that's what I put also, number 3.
That's what I think that one's mixed up from like the A, B, C, and D are not in order from what they were on the quiz, on the actual.
Yeah, because I wrote down B on my answers.
Yeah, I put A, and I put it as the you can apply the central limit theorem, but because it's larger than 30, right?
Yeah.
That's the one I put. I put D.
Or you read the question that you put, Brian.
I put yes, the distribution of the mean for each sample is normal since the researchers can apply the central limit theorem because the sample size is large enough. Right? That kind of explains why it's normal.
Yeah.
Sorry, guys.
No, you're good.
So is that right? Thinking that?
No, I'm just confused because I think they're both right, is what I'm.
I think they're both right, but I think that the one that says the central limit theorem explains why it's normal.
Okay.
Does that make sense?
Uh-huh.
That's kind of the way why I went with that.
Okay.
But
And
I don't know. You guys
just
feel free to contradict me or whatever if you feel like it's not.
well, you have a principle to back up your answer there, and I was just trying to extrapolate based upon the sample size. So.
Yeah, I agree. That makes sense to me. So.
Okay, so number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Be number 1, right?
I chose the confidence interval. The mean is known, and
I put B.
Yes.
you put that it's unknown. Oh, we dropped him again.
Looks like he's. Oh yeah, he dropped all the way.
But if you look up above to see what the sample size is and the do we have that information?
Sorry, guys. I don't know why my computer does that.
That's okay.
What did you guys put for that? What?
I put using dependent samples, but that was kind of a guess, so I have no idea.
So it would be. Jack, can you not do that?
I guess that would be wrong because
that
doesn't even make sense. Yeah,
yeah,
sorry.
because if you pick one female, you can pick any of the other males, right?
Right. Yeah.
I put confidence interval for mu when standard deviation is unknown. Because it doesn't give us a standard deviation, but it's not a dependent or an independent sample. Well, no, it would be an independent sample then, right?
Right. Yeah.
Yeah. So it's got to be the independent sample.
So when would those other two, like the confidence interval for mu, when standard deviation is known and unknown, when would those be used? Would those be used for the t-score, z-score, like those types?
Yeah, I think it's when you're only dealing with one set of, that's the way I kind of look at it. If you're dealing with multiple sets of data, when you're comparing multiple sets of data, then you have to do the independent versus dependent. And then that's kind of the way I look at it. And I don't know if that's technically the right way to look at it, but I feel like it works.
I asked the TA about that. He said dependent means that it's interrelated and it's like cause and effect, or it has to be linked to something. Independent is a separate thing.
Yeah.
Just like the word says.
Okay.
Yeah.
Okay. So number 5. A researcher is interested in estimating the saving account balance of customers at a large bank. She obtains the saving account balance from a random sample of 30 customers. A 95% confidence interval for the mean saving account balance of bank customers found to be $3,402.08, and then $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
Can you guys even hear yourselves over my kids screaming?
I think the answer is if you compute a 99% confidence interval rather than a 95% confidence interval.
I would not do that one because you'd multiply it by a larger number.
Yeah, so if you did a 99% confidence interval, I kind of look at that as it makes it a wider gap in order to give yourself a higher percentage of finding the mean, right? I put obtain a balance of 90 bank customers rather than 30.
I did as well.
Does that make sense, Wanda?
Yeah, because the more you increase the numbers, the more you get a better, insight into things.
Exactly. So, like, if you want to increase your chances of actually finding that mean, the true mean within that data, then you need to make that confidence interval larger to increase your odds, right?
That makes sense.
Okay.
Okay, so a factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the 2 mean lengths of the shafts. Input your answers for the margin of error, lower bound and upper bound.
That sounds like we have to open up that little thing.
That sounds like that was different than the preparation quiz, right?
Yep, it sure is.
Oh, yeah.
I think we have to do it by hand.
Yeah. So 95%. Oh, well, no, it's the homework.
It isn't?
Right? Because for the confidence interval, oh, it is. Never mind. It's wrong. Or it's different.
My kids are tired. We just drove 4 hours and they're hungry. So, sorry.
I'm sorry. Can you think?
No, it's all good. So, don't we need data? I guess we can find the margin of error, I guess, if we have the sample size of 4, right? Oh, so I found the margin of error. That was one of the questions. The margin of error that I got for this was actually,
I think it's different than the.
okay.
Food.
Mom's home. Did you guys find the margin of error on this one? I kind of had a hard time doing the math on it.
So margin of error could be 1.96, right, times. Oh, I have to remember.
It's the equation is margin of error equals 2 times the standard deviation over the square root of n.
And the end's 30.
The n's 4, right? 4 drive shafts.
Yeah.
I'm question 5. Whoops, hold on. I gotta get back down to you here.
Sorry. Are you guys there? Did I lose you?
No,
No,
we're
you're
still
here.
here.
Sorry, say the equation again.
It is m equals 2 times the standard deviation over the square root of n.
Okay.
So do we have all the information to put that in there?
So we have n.
Yeah.
We're only missing. Yeah, we do have that. Oh, okay.
We have this.
What was I doing on that question on the preparation? Oh, they asked you to solve for n or something. I don't know. We can do it. We have the info.
Input your answers for the margin error, upper bounds and lower bounds. So that's the plus and minus thing.
Yep.
So when would you use, sorry, the 1.96? Because that's the confidence interval. Isn't it z times? I'm just...
Don't worry, McKenna, we're all in the same boat here.
I'm like so lost right now. I don't know. Can't wrap my mind around things. Let's see. Yeah, because isn't margin of error z times the standard deviation over n? Z would be 1.96, right? Did we lose him again?
Oh my gosh, guys, I'm here. So margin of error.
I thought the equation for margin of error is z times the standard deviation over the square root of n. And z would be 1.96 because it's a 95% confidence interval.
No, I'm just saying right here.
You might be right. I'm not 100% sure. That's what I had written down. Oh, you're right. Z times the standard deviation. Oh, probably because I wrote a 2 in for z and probably at one point messed that up. That's that's what it was. I had the exact same equation, but I had a 2 instead of a z.
Oh, gotcha. Okay. I was like, I've never heard of this equation. What is wrong? Okay.
Well, how
so then I get 1.96, right?
Yeah, because that's the 95% confidence interval. You're right. Yep.
Why do we guys do it so?
By 2.
So it'll be 1.96 times 2 divided by the square root of 4. So it's 1.96 times 1, so it's 1.96, right?
Right.
And then, so that's our margin of error is 1.96.
So then this is the question on number 5. So our lower bound would be 998.040.
And what's the equation for that one?
So that one is to find the margin of error. You add it to the lower bound. Sorry, you subtract it from the mean. So our mean is 1,000. So you subtract 1,000 minus 1.96.
Yep.
So it's what minus the mean?
So it's 1,000, which is your mean given in the problem.
Yeah.
Minus what we got from margin of error, which is 1.96.
And then our upper bound's 1001.96.
I'm still subtracting, guys.
No, you're good.
So the lower bound is 998.
And
Is
then
that correct?
0.04. In the individual preparation, it had 0.040. So I don't know if we add the 0 at the end. If it, I don't know.
It does say, when calculating anything, please remember to round to the near 3 decimal places. So probably.
Okay.
When I have a question on the upper bound because my calculator is getting 1,000 plus 1.96 equals 102. I think my calculator is rounding it up.
Yeah, it is.
So
So it's 1001.960. And I wish I could remember how to tell you how to fix your calculator, but I can't remember.
Look, I almost fell.
I hate how the quiz, like they mix it up just enough to throw off all the numbers that you wrote down for your preparation. So you're like not sure which ones are which.
Yeah, because now we're on number 9 in the quiz and 6 on the.
Yeah.
Wanda, did you get that figured out?
in my calculator, 1,000.
No, the so the upper bound is 1001.960.
And the lower bound was 998.
0.040.
On question 7?
I want mine.
Yeah. Your calculator must be rounding for you.
I want
What was the answer again for 7?
998.040.
998.040.
Correct.
Okay. I'm calculating it wrong somehow.
Okay,
And
number.
you're getting, my question is on question 7. You're getting 998.040 by subtracting, I'm missing something in my equation. 1,000 minus 1.96?
Yep.
Uh-huh.
Okay.
Let's make sure.
Because I'm subtracting 1,000 minus 1.96, unless I'm supposed to be doing something squaring it, and it's equaling 998.
Your calculator, I am thinking, is rounding it automatically for you. Sometimes if you mess with the settings, it'll do that.
I see what you're saying.
Yeah,
Okay.
and I can't remember how to tell you how to fix
It's
it. I
actually,
used to be able
it's
to.
rounding to the nearest whole number.
Yeah.
green.
Okay.
Try, what kind of here, show me your calculator in the camera. And I can see if I can tell you how to fix it. Oh, just kidding, my camera's frozen.
It's a T1 Inspire CX.
Yeah, so if you hit at the very top left, there's a blue, like a second button. So hit that and then hit the 0, and it should reset it for you.
Look at you, McKenna. You're a calculator whiz.
I just remember this from like 5th grade.
I must have been totally absent for 5th grade then, because I don't remember.
It's the thing. We all played with our calculators. So.
All right.
It's not moving.
So question 9 is the question that I, for some reason, could not figure out the math to find the value of n. I guess you could just plug each one in.
Yeah, that's what I did.
That would work. I tried to do it algebraically, and I couldn't remember exactly how to do it algebraically.
Gotcha. I can't even remember. I just can see all my math and not know what I was doing. But I got 38416.
38416. Okay.
Uh-huh. Wanda, are you still there?
I'm still here.
Okay. So for number 9 on the quiz, did you get 38416?
3 point. If I don't put a comma in it,
Then you.
I've done that before and got my
Okay.
answers wrong.
Oh, really?
3.016.
I didn't have any points. I just had 38416.
3.8. No, I didn't get anything because I'm not knowing how to do it.
So for this one on the, I think Brian, are you still there? No, we must have lost him. So on this one, so the way I did it was because on the, like the individual prep, it gave you like a list of answers to choose from.
Mm-hmm.
So I took the equation z times the standard deviation over the square root of n, which is your margin of error equation. And for n, I plugged in each of the answers until I got what standard deviation, the correct standard deviation. If that makes sense.
I wish we just had a chart to go
Sorry,
in.
the correct margin of error. Sorry. So this is kind of what mine looks like.
You guys are
So
super patient with me. Sorry. I don't know why I'm.
No, you're good. I'm just explaining how I got number 6 to Wanda. So for your margin of error, your equation looks like 1.96 times, and then this part's going to be a fraction, 0.01, which is your standard deviation over the square root of n. And then you should get the answer. You're looking to get an answer 0.0001. So what I did is, because we don't know n, I went through each option for an answer and I plugged in n until I got that margin of error that they're asking for. And when I did that, I got 38416. Does that make sense?
It does, in a convoluted way. Yep.
Yeah, I kind of did it backwards.
But
Another way you could do is just solve the equation 1.96 times 0.01 over the square root of n. I actually don't know how to solve that. Oh, never mind.
Yep. Yeah, that's what I tried to do. It didn't work out too well. I like your idea better.
Yeah, because there's 2 equals. So, well, I guess
It would be 0.0001 equals z times 0.01 divided by the square root of 4. I don't know. But you got the
Okay.
answer. Oh, that makes sense the way you did it.
Okay. So number 10, the mean area mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses are, it would be D.
null equals
We lost.
null.
Yep, D. That's what you guys got, right? D?
I concur
Yeah,
because
that's what I
Oh,
got.
I thought I lost you again.
it says there smaller than, so that means less than.
Yep.
Yep.
So that's the alternative hypothesis.
Yep.
Okay, number 11. In a statistical test of hypotheses, we say we reject the null hypothesis with the level of significance alpha if p is less.
Less than alpha. Yep. So B.
Okay. Number 12. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
What did you guys?
I said yes.
Yes, it is. It's enough data to do ANOVA.
I put.
And it says it's already with nearly equal. So are they bell-shaped?
So it would be yes, there's enough data for the bell-shaped, no outliers, standard deviation nearly equal.
That's what we put.
Perfect.
Okay.
13.
I'm just going to read the question.
So this one, I mean, we can kind of just summarize because we've read it before, right?
Yeah.
So I put it's a type 2 error. This one, these type 1 and type 2, I kind of get them mixed up a little bit, but for the type 2 error, it's they said it's true, but it's really not true. So yeah, that's what I deduced would be a type 2 error. So it would be D, right?
Right.
Is that what you got, Wanda?
Yes.
Perfect. And then 14.
The question is if the level of significance alpha is still very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
So it'd be A, right? If you're reducing the probability of creating 1 error, then you're increasing the probability of creating a type 2 error, right? So
right.
A. And then 15. Type 2.
15. The nicotine content in cigarettes of a certain brand is normally distributed with a mean, mu, and a known standard deviation equals 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand gives a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
How did you guys solve this one?
Right? You reject the null?
Yeah, you reject the null. And did you guys find the z-score by hand and then put it into the applet to get the p-value?
Yeah. So it's X bar minus the mu over standard deviation divided by square root of n.
Yep. And then that got 1.764. And then put that into the applet and you get a p-value of 0.039.
Mm-hmm.
Perfect. So it would be D. 16.
On 15.
What's
I'm
up?
off here. We rejected the ha.
Yeah, the null hypothesis.
Which is H of O, or H of 0.
So that's number 3, correct? Failed to reject the HO?
We did reject it.
You reject it. Because the p-value is less than
The standard, the
the
mean.
level of significance.
Okay, so number 16, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I put independent.
I put. I have to like continually go back and forth because I just put the letter. This is 13, right?
Yeah.
I put D. So yeah, I put independent. Is that what you put?
Yeah.
Okay. Did you put that too, Wanda?
No, I put C on number 13.
Which
I
is
put a question by it.
Which is a deep. You put dependent. So
they're not dependent on each other, are they?
no.
They're independent.
So what I think is, when I think of that, I think if I changed one of these statistics, would it affect the other? And if it does, then that's dependent. And if it doesn't, it's independent.
That's a very good way of thinking about it.
Yep.
Okay.
Thank you for that example.
Uh-huh.
But on 16, is it going to be
Independent.
Independent, so B.
Because it doesn't matter which way you go with it. They're all kind of like their own island.
Yeah, because you could pick one male, and it doesn't matter what female you pick. There's not one male and one female that are tied together in any way.
That's not interrelated.
Yep.
Okay.
17, an educator is interested. Sorry, Wanda, what did you say?
I was going to read it, but you're reading it. Good, go for it.
Okay. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
That's a dependent.
Dependent, and so it'd be D.
Mm-hmm. Correct. So number 18, of the 4 types of confidence intervals listed below, which one is appropriate for the situation?
Oh, here it gives us a little thing to click on.
Yeah.
I put confidence interval for mu when sigma or when standard deviation is unknown. Okay, Everett. So I put
What question is that?
A. I put A. We're on 18, and that was on the homework though. That was question 15.
The thing I had a question about this is like when I enter the data, then I know the standard deviation, but I guess that it would be unknown still.
Correct. So right.
I'm assuming because I think at any point you're going to be able to find the standard deviation, so they wouldn't even have that.
Yeah, because if you had the standard deviation, that's a good question though. I kind of never thought of it that way. I just kind of looked at it as, well, they didn't give us the standard deviation.
Yeah, but I think that's kind of what they're saying is that they didn't give it, because in the other problems it was in the question. So I think you're
okay.
Right.
I guess we'll find out when we submit the quiz.
So the confidence interval is the mu, which is when you open that up, there is a mean, but is there a standard deviation? Is it known or unknown?
Unknown. Because it doesn't give it to you in the problem. It's kind of what we're thinking. We're not 100% sure. But. So it's the first option on the quiz.
Okay. Yeah, so when she's done changing the diaper over. So 19.
But there is a standard deviation on that. I put it under the one sample t-test.
Yeah, once you, the fact that it's a t-test, not a z, tells you that it's right? Isn't the T
Yeah.
score is when you have
When it's unknown.
Thank you.
Mm-hmm. So I think he dropped the call, but you back? Nope. Okay.
He's got to come back. So 18 is the confidence interval for the mu when the standard deviation is unknown.
Oh, I think you guys are blocking me
Correct.
out. I think that's what it is. You're like, "Okay, Brian, stop talking," and
Every time you talk, we just hang up.
McKenna's pushing a button or something over there. Like, stop talking, Brian. What I was saying is, I don't know if you heard me, but the fact that we're doing a T score to begin with tells us that it's the standard deviation's unknown, right?
Mm-hmm. Yeah.
Okay. All right, I'm going to a quieter place in the house.
So number 19, which of the following is the 95% confidence interval for this analysis? Input your answers to the margin of error, lower bound and upper bound. So the margin of error, oh, it's different than our notes. Shoot.
Okay.
Oh, I guess it gives it to you.
So we can compute we didn't have to compute the margin of error, right, in our homework.
Not in our homework, yeah.
But
So
we
now I
can-
have to put this data in.
We can get the.
Oh, we can get it by.
We'll get the data from the spreadsheet, and then we
Margin
can
of
compute
error,
the margin of error, right?
Mm-hmm.
Okay. Let's see.
That is what I needed to know the equation for this margin of error, because we had it before here as m equals z times standard deviation over square of n times 2.
Correct. Yep. No, not times 2.
That was my mistake saying times 2. That was all me. All right. I have like a million windows open with.
I'm trying to get which.
This is the dissolved
Situation.
organic, right? All right.
I'm talking about.
So it would be a one sample t-test. Okay, there we go. So if we know n, so 95% confidence interval.
So was it 1.896?
Yep. I was like, I left my calculator at home, so I'm trying to do it all on my iPhone. And I was like, I'm not sure if I put that in right. That's what I got, 1.896 rounded up.
It's pretty impressive you can do that by hand because
Mm-hmm.
I can't do anything by hand. Okay. So it's 1.896, and then our lower bound is 11.168,
Correct.
and our upper bound would be 15.217.
Yep.
You on the same page, Wanda?
Nope, trying to get there. I was just off on my
Okay.
other screen there. So question 19?
1.896.
And the lower bound is
11.168.
11.168.
Right.
Okay.
And then 21 is 15.217.
$15.217.
Right.
I need to just get my sheets open.
So 22. So we have the Hummers in Los Angeles and New York, Group 1, Group 2. And we're trying to compare the true difference of the mean list prices between the two cities. So it would be an independent samples test, right? Confidence interval difference of the mean using independent samples.
Yeah, that's what I put.
Okay, because it doesn't depend on which Hummer you select from each city.
Right.
And then, so then the lower bound, negative 423.238.
Yes. In the quiz, it had us round, so I wrote the rounded number. So I have the 423. So,
423.
but then this one's telling us to round to 3 decimal places.
Yeah.
So I don't know why.
So it's mean negative 24.
Negative 423.238 for the lower bound, and then the upper bound is 5417.336.
547.
5417.336. Okay.
And then what is the correct hypothesis test? So this one I put ANOVA.
Me too. But the only question I had is, oh, never mind. I thought it said ask for a T-score in 26, how it says calculate the test statistics. I was thinking T-score, but that would be the F-score, right?
Yeah, the test statistic is F-score.
F-score. Yeah. For some reason, I was thinking when I went over that, I was like, well, it's got to be an ANOVA, but there's no T-score. It's an F-score.
Yeah.
All right, cool.
Thank you, because that was my big question on my homework. Because,
All right. So so 26 would be 7.978.
Yeah, that's what I got.
And then the p-value is tiny number 0.002.
Yep.
And then, so it's less than, so we reject. Reject is sufficient.
So
we have, so then 28, we have sufficient evidence. Sufficient evidence.
it's different.
That the mean body density between all the groups are different.
So C.
Yeah.
Oh, all of the groups are at least one. Wait, there. Oh, wait.
Or one of the groups. It says the bottom one.
Because our it's got to be different, right? It's got to be A.
Well, A and C are the same thing, except for one is saying that all of the groups are different, and then C is saying that at least one of the group is different.
No, C is saying that the groups are the same, right?
No, it's saying.
The third
sure.
one down.
Oh, I'm sorry. The D.
Oh, D. Oh, gosh, there's such a tiny little window you can see.
Yeah.
I didn't realize that there was a whole bunch more.
So there is sufficient evidence to conclude that the mean bone density of all three groups is about the same. Because if you take that one rule, the higher versus the lower, and times it by 4, but this is an entirely different concept, isn't it?
Yeah.
So, McKenna, which one are you saying you think it is?
Well, I just don't know if it's. Sorry, I'm plugging in my laptop really quick. I just don't know if it's, because I know they're both sufficient and then it's different, but I don't know if it's different from. So from A to D.
I think it's A.
Okay.
That's just what I don't. This is one thing that really kind of I'm not 100% on. I feel like I don't fully understand what exactly when you say it's sufficient. So when you're saying it's sufficient, you're rejecting the null hypothesis. And our null hypothesis is what? Are you there? Oh, there.
Yeah, we're there. I'm listening.
That they're not equal to each other.
Right.
So then are we
So
saying that they are the same? If we're saying that they're not equal to each other?
Oh, there is.
I'm probably confusing everybody by saying this.
Well, so
When you have
our null hypothesis is that they are equal, and we can reject it because our probability p-value is less than alpha. So we know we're rejecting it, so we know that it's going to be different.
Yeah, so I think it's A.
Okay.
I mean, we can go to the end and have one person submit it, and then we can see.
Well, we all get 2 tries, so we'll.
It's
Okay, so I'll go with A as well.
Yeah, me too. We'll go with A and then C. I that's what makes sense in my brain, but my brain's kind of crazy, so I don't know. All right.
Okay, so 29. What is the correct hypothesis test for this?
Well,
Oh, this is a different. We don't have this one, do
That's
we?
about this is about the airplanes. Oh yeah, it was in there. Direct flights. That
Oh
was
yeah.
on question 23.
Oh, so I put independent sample tests.
I put independent also.
Are you there, Brian?
Yep, I'm here. Sorry. I'm just, this is the one question I didn't do before we came together, so I'm just reading it real quick.
Let me bring it up.
Yeah, it's got to be an independent, because I remember this question though from one of the quizzes. We used this data for one of the quizzes.
Oh, do we?
My question is, when I did the two sample t-test for the means, the 14-day and the 90-day, my p-value is not right.
Oh.
My p-value doesn't match any of their answers. So my question is my t going to be the same? You know, I don't know what I did wrong. So that's why I'm asking you. I put the 14 days first and then the 90 days. I put it in a two sample t-test.
Yeah, so you do two sample t-test. And then what did you get for your p-value?
I got 0.403623661.
Okay, so are you changing it to...
It's 95% confidence level, right?
So you do the 90 and 14 day together. Let me do it really quick so that I can explain it better and see what you're talking about.
Yeah, I pasted the 90 in there and the 14 and then the 90 into the two sample t-test. And I checked and I verified that I got all the information in there, because sometimes if you cut it off, it throws your answer off. So you got to make sure you copied and pasted right too.
Mm-hmm. Okay, I see. You got 0.404.
0.404, correct, for my p-value. But if you look at their answers, none of those match. So I'm thinking I did it wrong.
Yeah, because when I just put it in now, that's what I got. So let me...
Because if you look at the answers in your homework, in the review,
Yeah.
it's not matching those p-values there.
So I'm wondering if it is a paired sample test then. Let me put it in the paired sample and see what I get.
Part of me remembers this, and I think I put it as independent, and part of me thinks that I got it wrong or something, and that it was dependent. That's kind of what I was thinking in my head, but
because I think that I did this on the homework too. That I was like, I put it in the independent, the two sample, and I was like, oh, none of that's right. So then I went and put it in the paired, and that's how I got my answer.
So is it going to be the paired sample t-test or the two sample t-test? Well, it's two samples. That's why I put it in that one. But my p-score is off in my homework.
But the question is, are they independent or dependent? Is what we're trying to decide if they're dependent or.
To put which test were.
So if it's paired sample t-test, then that means they're dependent on one another.
That's why I put them in the two sample t-test, because I thought they were independent.
Is the p-value of 09 or 0.095?
Yeah, that's an answer.
That's an answer.
Yeah.
Yeah.
So is it going to be
what was the answer?
So it's got to be a paired then.
So I'm going to put my information in paired then.
Yeah. 0.0956.
Yeah, that was B in on your question 23. On that series.
Yeah.
And then it said, what's your test statistic then in it?
It is 1.685.
Okay, that was in the letter A. So it is a paired sample test.
Yeah. Question is why?
Yeah.
Because I kind of see what they're saying. So they're saying that they're checking the same destination. So one destination has to be paired with the other destination, I guess.
I don't know.
But it can give you at a different time.
So what did you get for the p-value again?
Let me tell you. 0.096.
Okay. Yeah. Okay. That's what Mine, when I put the data in, the first like 6, it doesn't get the mean for you, so you have to do it by hand. Or get the difference.
Shouldn't you what?
When I put it in the descriptive in the paired sample, and it gets the difference for you, the first 6 or 7 don't work, and so I have to do them all by hand. And then.
Do you have this document saved on your desktop?
No, I need to. I think I'm gonna download it brand new, so hopefully it'll.
Yeah, I wonder if you just need to. I wonder if you accidentally hit something.
Deleted
and deleted the equation.
Probably.
Yeah, I mean, my only worry about those answers is that when you copy and paste them in, there's some gaps in it,
Yeah,
I think there was a question to our instructor, and he said it didn't matter.
Oh, okay.
Okay.
Because I was like, I don't. Yeah, that would be silly if they did that and it mattered, because that would screw everybody up.
Yeah.
All right. So 32. Oh, sorry. Did you guys get 31 then?
Well, right now I want to see for myself that cutting and
right.
pasting is going to do it. And I'm not a very good cutter and paster.
That's all right.
I'm not very efficient. All it gives me is garbage. It gives me this hash mark div \0 when I put it in a paired sample t means.
I wish I could see your computer.
Is it calculating the differences for you? So variable 1 and variable 2 and differences, those sections? Is it filling out the differences for you?
Yeah, but it's not giving me a T or a P.
Okay, and then under their spot that says confidence interval, null hypothesis, and type of test, what do you have under those?
I have my confidence level is 0.25, null hypothesis 0, type of test is not equal to.
And then your confidence interval, instead of 0.25, it should be 0.95.
I don't have any of that information in there. It's a hash map. I'm going to have to get my IT person that's not here to help me with this. So I don't understand what's going on. Because it should be a paired sample test, because Brian did it and he got those answers that are in our homework.
Yeah.
So it is a paired.
And our type of test would be not equal to, right?
Right.
Okay, good. I'm just double checking.
Hold on here, because I'm clear back into my little other screen here.
Well, let me actually make sure.
So on question 32?
I put B.
I did too.
So we reject because the p-value is less than the alpha, so we reject. So we have sufficient evidence to say that there's a difference in the mean cost of ticket purchase 14 days in advance compared to 90 days in advance.
And I have 25 blank still. I didn't write that in. Who's being in there?
Sorry, that's my phone. 25. is an ANOVA test. So I submitted it.
You didn't do too well.
Oh, dang it. I forgot to switch number 29 from independent to dependent.
Oh. Oh, I did too. Dang it.
So 28 then. So 28 is A is wrong. So I was wrong on that.
So it must be D then. Write these down so I can go back.
Yeah.
So you go back and fix it though, you have to do the whole quiz again, don't you?
Yeah.
That's always my like.
McKenna, why don't you just say, Brian, you're wrong. I had the right answer to begin with. For crying out
I
loud.
didn't know. I
So-
just trusted you. It's okay.
Yeah, don't do that. Don't do that. Oh crap. So our margin of error was wrong for 19, dang it.
Yeah, I didn't.
I always get I have never gotten that question right on all the quizzes and stuff.
I'm just gonna start doing it by hand.
I don't
Oh wait, we did do it by hand. Just kidding.
we did do it, yeah, I did do it by hand for
Shoot.
crying out loud.
I don't know.
And it's not it wasn't a type 2 error, it was gotta be a type 1 error then, right? For 13.
Right.
Bummer. Well, it's not too bad. So then 3, you guys were right again, and I was wrong. I think so. It's got to be the distribution of the mean of samples normal. It's got to be C. Again, you guys are trusting me, and you shouldn't. All right.
Okay, well,
Well,
good
thanks,
luck on the
guys.
test, guys.
Good luck. I'm probably not going to be able to take it till.
We have to take it by tomorrow by 11. It closes out at 11 tomorrow.
It
I'm
does?
glad you told me that because I
Are
was
you
waiting
sure?
till Saturday.
Yeah.
I'm pretty sure it's Saturday.
Well, that's the test, the main test that closes out Saturday. On these Google things, you only got like 24 hours to do your second test.
Oh, yeah. The
Oh,
main
yeah.
test. Yeah, the main. Oh, I was like, you just scared the crud out of me because I'm flying all day tomorrow to get to Miami. So,
No, the
Was
main
it-
test, you got till Saturday.
okay,
Okay.
I'm taking that on Saturday. I'm gonna redo this one right now. But
I
oh,
was
you,
like, I work all day.
you
Okay.
just
I thought
scared
we were
me,
still
Wanda.
talking about, I didn't mean to scare you. We were talking about the test.
All right, guys.
We
Well,
weren't
good
going
luck.
outside the box yet.
Good luck, and we'll talk to you later.
Okay,
On
see
that
ya.
one, I'm figuring the mean. How do you calculate it? Let's just do it
Okay.
now.